Since their invention, nuclear weapons have cast a long shadow over humanity. These weapons, with their unimaginable destructive power, represent a threat unlike any other. Understanding them is not about glorifying their power, but about comprehending the gravity of what's at stake. Our exploration begins with the science behind these weapons, delving into the heart of the atom itself. From there, we'll journey through history, contrasting the devastating impact of the Hiroshima bombing with the terrifying capabilities of modern nuclear arsenals. The differences are stark, highlighting how technological advancements have amplified the potential for destruction. But our focus won't solely be on the science and the statistics. We'll also examine the human cost of nuclear weapons, exploring the immediate and long-term consequences of their use. The blast radius is only the beginning of the story. Radiation poisoning, environmental devastation, and the potential for global famine paint a grim picture of a post-nuclear world. Finally, we'll turn our attention to the ongoing efforts to control these weapons, international treaties, non-proliferation agreements, and the tireless work of diplomats and activists offer a glimmer of hope. The path to a safer world, one free from the threat of nuclear annihilation, is fraught with challenges. Yet understanding the stakes is the first step toward ensuring humanity's future. At the heart of a nuclear weapon lies a process that unlocks the immense energy stored within atoms. There are two primary types of nuclear weapons: fission bombs and fusion bombs. Fission bombs, like the one detonated over Hiroshima, work by splitting heavy atoms such as uranium or plutonium. Imagine splitting a log of wood. The act of splitting releases energy, and in the case of a fission bomb, that energy is released in the form of heat, light, and powerful radiation. Fusion bombs, on the other hand, work by fusing light atoms, typically isotopes of hydrogen, together. This process, which powers the sun, releases even greater amounts of energy than fission. Think of it like squeezing two pieces of clay together. The force of the squeeze can fuse them into a single piece, releasing energy in the process. Fusion bombs are significantly more powerful than fission bombs, and their development marked a dramatic escalation in the destructive potential of nuclear weapons. The key difference between these two types of bombs lies in the way they initiate the nuclear reaction. Fission bombs require a critical mass of fissile material to be brought together very rapidly, usually through the use of conventional explosives. This triggers a runaway chain reaction, releasing a tremendous amount of energy in a short amount of time. Fusion bombs, however, are more complex. They require incredibly high temperatures and pressures to initiate the fusion reaction. To achieve these conditions, a fission bomb is often used as a trigger. The fission explosion creates the necessary environment for the fusion reaction to occur, resulting in a much larger and more destructive explosion. The atomic bomb dropped on Hiroshima, Japan on August 6, 1945, unleashed a force equivalent to about 15,000 tons of TNT. The devastation was immediate and immense, instantly killing tens of thousands of people. Buildings within a mile of the blast were reduced to rubble, and fires raged through the city. The world had entered the atomic age, forever marked by the horrors of that day. Modern nuclear weapons dwarf the destructive power of the Hiroshima bomb. Today's arsenals contain weapons with yields measured in the hundreds of kilotons or even megatons of TNT. A single one of these weapons could obliterate an entire city, causing widespread destruction and loss of life on a scale unimaginable in 1945. The difference in destructive power is staggering. To put it into perspective, if the Hiroshima bomb is represented by a basketball, a modern thermonuclear weapon might be the size of a small house. The blast radius of these modern weapons extends for miles, potentially engulfing entire metropolitan areas in a single devastating explosion. The heat generated by these explosions is intense enough to vaporize everything within a certain radius, while the shock wave can level buildings and create hurricane-force winds.